Let's discuss solve problem 4 on singly linked list. The following C function takes a single linked list of integers as a parameter and rearranges the elements of the list. This is the function rearrange, which receives a list pointer, which is the pointer to the first node of the list. Okay. The function is called with the list containing the integers 1, 2, 3, 4, 5, 6, 7 in the given order. So list consists of all these integers in the given order. What will be the contents of the list after function completes execution? These are the options available in front of you and you need to identify the correct option. This question has been asked in GATE CS 2008. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. Let's see this rearrange function more closely. This function receives list as an argument. This is the pointer to the first node of the singly linked list, and this is the singly linked list available in front of us. This list pointer is pointing to the first node of this list. This contains this address. I'm assuming here that the address of the first node is 100, address of second node is 200, address of third node is 300, and so on. These are just my assumptions. But these elements are already given in the question, so I took it as it is. Inside this rearrange function, there are two pointers declared and one temp variable declared. We have these two pointers p and q and temp variable. Within this if construct, we are checking this condition, not list or not list next. Now what does it mean? List contains this address 100. Obviously we can replace this by 100. We know that 100 is some value other than 0. This will be treated as true. Not true means false. So this becomes false. What is list next? We know list next is 200, so we can replace this by 200. Not of 200 becomes false because 200 will be treated as true, and not of true means false. So false or false gives false. So this condition is not satisfied, let me tell you, so return will not get evaluated. Now if we try to understand the meaning of this statement, it simply says if list is equal to null or if list next is equal to null, then return. Because if list is equal to null, then we can replace this by null, and we know the value of null is 0. So not of 0 means not of false, which becomes true. Or if list next is equal to null, which means we can replace this by null, not of null means again true, so we can simply return from this function. Not list is equivalent to list is equal to null, and not list next is equivalent to list next equal to null. Now let's evaluate this particular statement. P equals to list, Q equals to list next. We are simply storing list inside P and list next inside Q. So it is clear that P will point to the first node and Q will point to the second node. Now let's check this condition inside while. Here Q is written. What does this mean? We know that Q contains some address, and that is 200. If Q contains null, then this becomes false because the value of null is 0 and 0 means false. Now if this Q consists of any other value, then it will be treated as true. Right now it contains this address 200, which will be treated as true. So we can get inside this while loop, isn't that so? Now let us evaluate this particular statement. Temp equal to p value equal to q value. Here inside temp we are storing p value, which means we are storing this value 1. So let's store this value over here. Now p value equal to q value. We are storing q value inside p value. That means we are storing 2 over here. After this step, we will evaluate this step. Q value equal to temp, which means 1 will get stored over here. And p equal to q next means here we will store this particular address 300 because q next is 300. So this 100 will get replaced by 300. Therefore, it is clear that Q is now pointing to second node of the list and P is pointing to third node of the list. Now, we will evaluate this particular statement. What does this mean? Q equal to P question mark P next is colon and 0. We know this is a ternary operator question mark with colon, right? Here inside Q we want to store something. Now what we will store? We will store the result of this particular operation. P question mark P next colon 0. Now what does it mean? If P contains null, then 0 will get stored inside Q. If P is not equal to null, then P next will get stored inside this Q. Now this is interesting, right? Because we know what this operator does, right? It checks this condition. If this condition is satisfied, then P next will get stored inside Q. If not satisfied, then 0 will get stored inside Q. That is what it means, right? So here we know that P contains this address 300. It will be treated as true. So P next will get stored inside Q. We can write this statement P question mark P next colon 0 as if P not equal to null, then Q is equal to P next, else Q equals to 0. So remember this statement. Now, it is clear that Q is equal to P next will get evaluated, which means that 200 is now replaced by this address 400. Because Q is equal to P next and we know P next is 400, so 400 will get stored inside Q. Now we will again check this condition. We know Q is not equal to 0 or Q is not equal to null. It is some address. So we'll get inside this while loop and we will evaluate this statement. Temp equal to P value equal to Q value. According to the statement, temp will store this value 3, that is this value, and 4 will get stored over here. After this statement will get evaluated, which is saying Q value is equal to temp and P is equal to Q next. Q value is equal to temp, which means we will store this 3 value over here, and then after that we will increment P, that is we will store Q next here, which is 500. So we will replace this 300 address by 500. After this again the statement will get evaluated. And we know that P is not null. So it is clear that Q is equal to P next will get evaluated. So here 600 will get stored. Now again we will check this condition. Again, this is satisfied. So we'll get inside. Here this statement will get evaluated, which means temp we can replace this value by 5 by this particular value. And here in P value we will store Q value, that is 6. After this in Q value, that is here, we will store temp, that is 5, and then 700 will get stored inside P. Again, we will evaluate the statement. We know that P is not null. So here we can replace this by Q equal to P next. And we know what is P next. P next is null. So 600 will get replaced by null. After this, we'll again check this condition. Now this time Q is null, right? You can see over here that Q is null. So it is clear that we'll get outside of this while loop. So this is the result so obtained. 2, 1, 4, 3, 6, 5, 7. Isn't that so? So it is clear that option B is the correct option. 2, 1, 4, 3, 6, 5, 7.